Rationalizers. Welcome to your Chapter 10, Lesson 9 notes. Continuing to talk about the other trigonometric functions. So this time we'll take those new ratios that are inverses of sine, cosine, and tangent, and now we're going to turn them into the inverse functions of sine, cosine, and tangent. So it's very interesting how this all kind of comes together. Remember that cosecant is CSC, secant is SEC, and cotangent is COT. So remember that as we're looking at the abbreviations, right? Cosecant, everyone has their cofriend. So sine goes with cosecant, cosine goes with secant, and tangent, that's the easy one, goes with cotangent, right? So everyone has their cofriend as we go along. Cosine's cofriend is secant, right? Because they all have a co. Basically, what we're going to do is we're just going to look at, hey, these are the values for sine in each of these major spots around the unit circle that create then the function, the unraveling of the unit circle. Well, their reciprocals are going to go right here. So this is very interesting because if you reciprocal sine of 0, you get 1 over 0, which is undefined, right? So you end up getting an asymptote for cosecant here. When you reciprocal 2 over radical 2, you have to rationalize that by multiplying top and bottom by radical 2. Okay, and here, down here, you get 2. Up here, you get 2 radical 2. Well, those 2's cancel out. So this ends up being radical 2 is the value here. When you flip this guy over, it's 1. And then we've got this one again at radical 2. And then, boom, again, you have an undefined, an asymptote, right? So what we're looking at with these is these are like above the actual peaks and valleys in the sine function and or below, and then we get to these asymptote areas. So when we're looking at cosecant and secant and cotangent, now it's not just tangent that has all the asymptotes. The cosecant and secant will also have asymptotes because of that flip that then creates an undefined fraction. Here, now you're looking at negative radical 2. You're still looking at negative 1, and you're looking at negative radical 2, but again, back to an undefined section. So I'm just going to stop right here and show you what that graph actually looks like. So here are those asymptotes that we were just mentioning, right? At 0 and 180 and 360. All those places where your sine value is 0, when you flip that over, now you've got a 0 in a denominator, you've got asymptotes. Now, this is what the sine function looks like, is this. So see how these are opposites? Exact inverse opposites of those. Okay. Let's take a peek at what secant ends up looking like, when you flip these guys upside down. Now, of course, similar values, we already know what's going to happen when we flip 2 radical 2, 2 over radical 2, and then rationalize it. But notice here, we're not undefined, right? 1 over 1 is still 1. Here it ends up being radical 2, but there is our undefined. Flip 0 over, now all of a sudden, what you're doing is moving your asymptote to 90 degrees and to 270 degrees. So that's similar asymptotes to your tangent function. Now these, of course, negative radical 2, negative 1, negative radical 2. Then there's your asymptote. Now you've got radical 2 and 1. This then looks like these guys. Oh, that's secant, or cosecant, Here's secant. So this then looks like these. So again, it's the opposite of your peaks and valleys, from, here's your asymptote, right? At 90 and 270. And it's the opposite of how your cosine function normally goes, where it normally starts here, heads down, and does the cup, right? And then comes back up. So this is the opposite of that, having your peaks and valleys right above. But again, these asymptotes blocking them from matching up and hitting actually at 90 and 270 because that's where they're undefined. We're dividing by 0. Not something we can have anymore, right? So it's just very interesting how secant and cosecant end up looking, okay? I just want to show you. Here's my secant and cosecant. Other direction. Okay, so I just want to show you secant versus cosecant. Secant versus cosecant. Okay. So just 90 degrees apart from being the same function. Just like sine and cosine are just 90 degrees apart from being the same function. Interesting how that works, huh? Okay. And of course, now we need to do the same for cotangent. So flipping this over. So when you're looking at tangent and cotangent, this is going to be very interesting because remember that tangent has these undefined areas, which really means that you've got 1 over 0 as your sine is 1, but your cosine is 0, right? Well, when you flip that back over, those are going to actually be areas where this is at 0. And when you flip this over at 0 and 180 and 360, now all of a sudden, that's where your undefined areas will be. Your asymptotes will be 180 degrees and 0 degrees and 360 degrees, right? Versus being at 90 and 270 like they were with tangent. Okay, so these values, of course, the same when you're flipping them over, 1 and -1. But now all of a sudden, I have to worry about where my asymptotes are going to be. So here is cotangent. And notice that tangent normally has asymptotes at 90 and 270, but here are the asymptotes for cotangent, and tangent is normally at pi. We're going up this way and then back this way toward the other asymptote. Look at this is the opposite. It starts with the 1 and then heads down to the -1. Starts with the 1, then heads down to the -1, gets your zeros in the middle. So it's just a little bit different from that tangent as far as that asymptote and then that direction. So when you're trying to identify it, that's what that difference is. And you can see it right here. Okay, so back to that sheet from before. All right, so my blue is my original tangent function starting at 0, heading up to 1 at 45 degrees, and then continuing towards the asymptote at 90, right? And then here's your 0 at pi at 180, and then there's your look, and there's your other asymptote at 270, and then of course you're down here in your negatives, heading back up to 360 and starting the cycle over for tangent. But the red is the cotangent, and look at that difference. And then you've got asymptotes at 0, 180, and then there should be one right here, but it's obviously not written in at 360. So the asymptotes for the cotangent are in the red, and you can see that our function actually comes the opposite direction. And again, it all makes sense because these are reciprocals. So speaking of, let's just take a peek at all of the reciprocal relationships. And then, of course, I had separately had each function pictures that I just focused in on. But here's all the reciprocal relationships. And you can see why we refer to sine and cosine as those sinusoidal functions that we use for our periodics, because they're the only ones that don't have these asymptotes that we have to deal with. Everywhere else, when we do these flips of these fractions, we end up with asymptotes. We end up with zeros at the denominators, and that's not a thing that we can actually deal with, right? And so that's why we get these asymptotes that occur. Honestly, when it comes to cosecant and secant in the cotangent and tangent functions, it's more about recognizing them when you see them than it is with dealing with them, because it's sine and cosine that we use to write our actual periodic functions in the world. Okay? So that's more what you will be kind of looking at. Okay? So one last thing is, if I put all this craziness together, everyone's just 90 degrees apart from each other. Sine is just 90 degrees from being cosine. Scooch this guy over 90 degrees and you got matches. The opposites are the dots, right? So the opposite of sine, the reciprocal of sine, is this cosecant. Okay, so meaning sine's peak, the opposite is up here for cosecant. Sine's valley, the opposite is down here for cosecant. Cosine is that cup, so the opposite of its valley is down here for secant, and then its opposite of its two peaks would come together as one cup in that top there. And then, of course, here's your tangent is blue. There's your tangent function. And the opposite of that guy, the dotted blue, goes this direction. And your asymptotes for those particular things. So it gets overwhelming when you go and put all 6 of these trigonometric functions on one graph. But again, like we've been talking about, sine and cosine are our only periodics that we can actually write actual real life scenarios using. Okay, the other ones are things that we have to just understand and identify more than anything else, more than use, right? So identify more than use when it comes to our other trigonometric functions. And that's what we'll be doing for our homework, is identifying which one is which and what the inverse relationships are. So match up those inverses back to each other, right? Sine and cosecant are inverses, cosine and secant are inverses, and tangent and cotangent are inverses. So matching up your inverses with each other, your inverse relationships, and then being able to identify the functions when given each in front of you. All right, we'll get to that homework and then we'll review for chapter 10. So guys, this has been the last new notes of your year this year. I will be seeing you very soon, Math Analyzers. Have fun.